the metabolism of drug, or we call it biotransformation. Why is the drug biotransformation necessary? The aim of biotransformation is to turn the drug to be inactive and more polar, so that the drug could terminate their action and more easier to be excreted from the body. Renal excretion plays a pivotal role in terminating the biologic activity of some drugs. Pharmacologically active organic molecules tend to be lipophilic and remain unionized or only partially ionized at physiologic pH. These are readily reabsorbed from good molecular filtrate in the nephron. Certain lipophilic compounds are often strongly bound to the plasma protein and may not be readily filtered at the glomerulus. Most drugs would have a long duration of action if termination of this action depends solely on renal excretion. In general, biotransformation reactions generate more polar, inactive metabolites that are readily excreted from body. Phase 1 and Phase 2 reaction. In general, all of these metabolite reactions can be assigned to one of two major categories, called Phase 1 and Phase 2 reaction. Phase 1 reaction, we also call it inactive reaction. Through Phase 1 reaction, drugs are metabolized to inactive drugs. Phase 2 reaction, we also call it conjugate reaction. Phase 2 reaction form highly polar conjugates. Look at this figure, Phase 1 and Phase 2 reaction and direct elimination in drug biodeposition. Phase 1 reaction generally result in the loss of pharmacological activity, although there are examples of retention or enhancement of activity. We will discuss it later. Phase 2 conjugation reaction leads to the formation of covalent linkage between the functional group on the parent compound or the Phase 1 metabolites and endogenously derived glucuronic acid, sulfate, glutathione, amino acid, or acetate. These highly polar conjugates generally are inactive and are excreted rapidly in the urine or feces. Through Phase 1 reaction, drug metabolites with modified activity or become inactive drug metabolites. Through Phase 2 conjugation reaction, drugs become more polar compound and are more easier to be excreted from the body. Drug could only have Phase 1 reaction or only have Phase 2 reaction. Phase 2 reaction may also precede Phase 1 reaction. Parent drug also could be excreted directly from the body. Through Phase 1 and Phase 2 reaction, lipophilic drugs will become hydrophilic and are more easier to excrete from the body. Here are some polar groups: glucuronic acid, glutathione, sulfate, acetate. If the drugs or metabolites bind to these polar groups, they will become polar compounds and are more easier to be excreted from the body. Phase 1 reaction do not always make the drug inactive. In some cases, metabolites with potent biologic activity or toxic property are generated. Example 1. Inactive products are converted rapidly to biologically active metabolites. Enalapril is ACEI, angiotensin-converted enzyme inhibitors. Is one kind of antihypertension agent. We will discuss it in later chapter. Is relatively inactive until converted by esterase activity to the acid enalapril. Here is ACEI drugs and their characteristics. Enalapril is parent drug. It has active metabolites, enalaprilate. Through Phase 1 reaction, its activity is enhanced. Example 2. Isoniazid, INH, is anti-tuberculosis drug. Through Phase 1 reaction, it becomes a hepatotoxicity metabolite. Multiple choice. 1. Biotransformation include A. Phase 1 reaction, B. Phase 2 reaction, C. Phase 4 reaction, D. Phase 0 reaction. The answer is A and B. 2. Phase 1 reaction is inactive reaction, B. Conjugated reaction, C. Through Phase 1 reaction, some drug activity could be enhanced, D. Through Phase 1 reaction, some drug may become toxic metabolites, E. Most drugs become more polar compound. The answer is A, C, and D. 3. Phase 1 reaction is only convert the drug to be inactive. The answer is false.